welcome back, everybody, for Chapter 2 of the forum. Hope everybody got replenished and hydrated back there. So our next speaker is Baruch Sadogursky, who is a developer advocate at JFrog, and he is a very prolific speaker on the topic of DevOps, continuous delivery, and automation in engineering, and he's always jetting around the world. It was tough to get on his calendar, actually, for the conversation today, so he'll be talking a little bit more. And Baruch also recently moved here from Israel about a year ago. So if you have any good Bay Area restaurant or activity recommendations, he'll be all ears. And he also just wanted to add that he was born in Russia, which is what explains his accent. So again, without further ado, hand it over to you.
Thank you. Hi, thank you everybody for coming. And we're going to talk about automation. And that's me, as Shorty introduced me. I'm a developer advocate with JFrog, at Baruch on Twitter and every other social media that even exists. And that's not me, but he is kind of nice as well. Okay, JFrog is a startup company founded in Israel. All the development is done in Israel. I was there up until less than a year ago, and then we have a headquarters here in Silicon Valley in Santa Clara, when I am now. We have a tiny office in France that's actually half of what it is now. It's an extraordinary, I think, 7 people. And we're growing, so that's JFrog. We have thing with frogs, as you might see, right? Oh, it doesn't work. Okay, now that's your problem, so you can hear me, right? Okay. We have 3 products: Artifactor, which is an artifact repository; Bintray, a universal distribution hub; and Mission Control, which allows you to control the missions on Artifactory and Bintray. All 3 products are about allowing you to take your code faster from the development to production. It's all about speed, release fast or die, and it's about DevOps. And DevOps are about automation. Right, so we're going to talk in the panel, I think, more about what DevOps actually is for different people, because from what we see, what we hear is everyone has its own understanding of DevOps, which is not aligned. So for me, for example, DevOps is a lot about culture and automation. So panel, okay, we'll do that. So panel will be more about culture, I guess, and this talk will be more about automation. So let's talk about automation. I guess most of you recognize this graph. That's the singularity graph, and the singularity is actually near. We see here points where the computing power overcomes the power of brain power of mouse in 2015. So we got this checked, and then very soon the brain power of human, and very soon the brain power of all the human brains combined by computers, right? So that's singularity. What it has to do with that's hard. What it has to do with our topic. Automation is about singularity, right? It's machines doing stuff instead of us. And that's actually the same for software, and it's actually more fascinating about software because software is built with software. So when we talk about automation of software that creates software, you got the idea. It is actually recursive. 3 laws of robotics, you probably all know them. And robots in software industry are different. They also have 3 laws. First, they are extremely cheap to build and discard. They are much cheaper than engineers, right? Second, they are repetitive. They completely do the right thing and sometimes the wrong thing, but in exactly the same way. And third, they don't have a Facebook page to procrastinate during the day. Some of them do, but that's an exception. Usually robots don't have a Facebook page. Romantic memories, the trees were high, we were young, and the releases were manual. Very rare, like quarterly releases, remember quarterly releases? Done by human, very specific breed of human called release engineers. We don't see them often now, right? And they were monolith. Talking about microservices and monolith, they were simple. Well, they were very complicated, but for completely wrong reasons. Thinking now about the releases 15, 20 years ago, they're a piece of cake for us today. Then it was a challenge. And it was a challenge because it wasn't automated. Today, that's not the world we are living in, right? We educated the consumers, and we are the consumers, so it's kind of self-driven, that we want what we want now, we want it fast, and if it's not now and fast, probably the company will die, right? That means that we cannot do things as we used to do them, and that means that we cannot allow humans to touch the process. What we actually aim is a pipeline from the development to production without human intervention. And that's exactly what the technical part of DevOps is about. Well, a lot of us feel that somewhere in this pipeline, people should look at it and approve it. And the technology today actually reinforces us with this assumption, right? Think about a couple of companies that do continuous deployment. What we can name Facebook, right? We know why we hate continuous deployment in Facebook, because it never works. The same with other companies that we know, and we are, okay, this is broken again. Well, that's because they do continuous deployment. Okay, hopefully it will work tomorrow, then we have 5 new versions. Right, so that's something that we know, we feel, a lot of us feel, and that's the reality. Well, it shouldn't be that way. And it's kind of a thing that never done until it's done by someone. So if we will have more and more examples of companies that do this continuous deployment without human intervention, we actually will start to believe that this is possible. And then the tools will catch up, because once it's the mainstream, it's a huge market, and everybody wants to be in the game, to be better than their competitors, and provide better tools with us. So this kind of prophecy that fulfills itself. Once someone starts doing it, we will start doing it as well. And of course, once this trend is building up, you cannot stay behind. And in the next 15 minutes, I will try to share with you what we believe is necessary to join this trend that is ramping up now. So first, let's talk about creativity for a little bit. That's actually something that my CEO spoke about yesterday in our offsite meeting, and it's good that I have 20 minutes to upload my slide this morning. So this is how creativity is happening, right? We start with the chaos, which leads to creativity to solve this problem, which brings to new reality, which gives us this feedback of chaos once again. And to enable this part, of course, the creativity, we need to be able to adjust to new chaos that was created by new reality. And out of all things, it brings me to talk about version control support. Because this is where developers are creative. That's exactly the place. And why so? The developers want to write crazy code. They are in chaos, they want to be creative, they have absolutely crazy ideas. Without good version control support, they will be afraid to do so. Because if what they write apply to a main branch of their development, it's very scary to do something which is not trivial. Talking about branches, now every developer can have its own isolated space to get crazy in, and then discard it very simply when they discover that it doesn't make sense, or merge it to the production code if it actually worked out. Right? And this is a trend. Compare the power of working with branches in Git to clear case or even subversion, right? It's a trend that's going on and on that allows experiments. And what I'm going to talk about is exactly that, allowing experiments. Now, how can we test whether this experiment was successful or not? We have machines. Machines are very stupid, but very persistent. They know how to do stuff. And now that picture that I can stare for half an hour, live in a case store. I go there and then I stand behind and stare at that. Other machines working is fascinating. Well, that means that we can test those crazy experiments on a huge scale. CI servers, Jenkins in this example, allow us to do that, and that's also something that they learned to do relatively recently, right? Think about cruise control. And now think about the matrix, the branch matrix support in Jenkins. How you can spin up automatically new Jenkins builds, new Jenkins projects for every crazy experiment that developers do. So you can see here how this isolated space in the developer working machine now being completely tested in your CI server without any effort. We have a place where going with experiments is hard, and that's of course hardware. Hardware is hard to experiment on because hardware is expensive, and hardware takes time to be created, and of course we don't want to destroy it. And the solution for that, of course, is making hardware software. Because once we do that, this problem is gone again. And that's, of course, another trend that we see now with virtualization and, of course, with Docker, right? This is what it's about. So we can spin up any hardware to pretend that we actually have a machine to run on experiments on, and then discard it if it didn't work, or keep it and sometimes make it actual hardware if the experiment was successful, right? If everything's good, we're going to procure the hardware machine that we need for that experiment. So that's another trend, and it's all builds up to the same place that we need to experiment more. Right? So, yeah, I mentioned a couple of them, and that's the trend that we see. Well, how can we test successfully what we experiment with? Whether those tests that everything works as expected enough, especially when we are talking about no human intervention, and what we do best is thinking about scenarios in which everything will fail. We're going to talk about the QA in a minute. So that's part of it. Not only we need to test that whatever works successfully, but also how it behaves when it breaks. And again, how can we automate it, how the machine can help? So Chaos Monkeys from Netflix is a great example. Right? They have a machine that actually fails servers on their production environment.
Randomly.
Randomly, right. Okay? And they force, those machines force Netflix to embrace the failure and to know how to deal with it. Well, people are still better in some areas. And of course, I'm talking about QA. The reason why people are better for now in QA is because our creativity gain, right? Good QA engineers can think of ways of failure that no machine can randomly produce. You know the joke about the QA engineer that walks into the pub, asks for a beer, asks for 2 beers, for 1,000 beers, for -3 beers, for a monkey. So that's exactly what machine cannot think of out of the box. But we see changes. We see changes in that field as well, and we do see robots that allow us to make a very interesting QA tests. And the hardest part is the UI. And the UI is hard because it is intended to be perceived by humans, not by the machines. So testing them by the machines, which by definition have different perception, is hard, right? So how do you test a web page? You check that the IDs of the HTML elements are present. You check the location of this element on the screen. But that's nice, but it's not what's important, right? A human can look at this page and say, well, it looks ugly, although the ID is present and the location is right. So that's a tough one, but we do see some very interesting approaches to that. For example, we can have a human that will record the test and then it will run by machine. And then when changes occur, again, this process can be automated to some way that we will authorize the changes and then it will be tested by the machine again. The problem, there is another very big problem with QA, and tests in general, and that's whether the tests are good. I mean, who tests the tests? We can have a great coverage in our unit test and our integration test, and they will be completely useless because they actually check nothing. And that has a solution as well. And it's actually called the mutational, that's excellent, the mutational tests. And that's another process which, like the cows monkeys, ruin your tests to verify that if the tests are ruined, they won't pass again. Because if you broke the test, for example, if your assertion was comparing something, and now you start asserting that the things are different instead of the same, and the test still passes, it means that this is a garbage, not a test, right? So there are cows monkeys which ruin not only your production code, but your tests as well, just to verify that your tests are meaningful. And that's very interesting idea as well. Very old one, I think been around for 30 years, but now with hands off the manual test and QA, it starts to be very important again. So all that allows those crazy things to happen. All those allow the developers to go nuts in their sandboxes, in their branches, being tested from different perspectives, etc., and then eventually throw away what didn't make sense, but keep what makes sense. And that's the big thing, that's the creativity. And it has a lot to do with automation as much as with DevOps. The future, as we see it, is there. It's even more robots because that's the trend. The experiments, the developers feel more comfortable with experimenting. They generate more and more crazy ideas that need to be taken care of by robots to find this one that will take the product, the company further and will do the next breakthrough. And the cloud is one of the enablers of this thing because cloud means, that's a nice picture, it has both the clouds and the robots. It's not a robot, but it's close enough. The clouds allow scale, right? There are no physical boundaries to how many robots we can generate on the cloud, and we see the trend that everything now is on the cloud. The CI is on the cloud, the QA is on the cloud, right? We have platforms that allow us to do tests running on dozens of different environments in the same time and completing in the same time as it was one environment. Why? Because everything is scaled out in the cloud. So the cloud allows us to do even more machines, which actually allow the developers to get even more crazy. Right, so just small summary of the robots and what they do. So any number of environments can be provisioned using tools like Chef and Puppet, etc. Any number of software flavors can be produced by tools like Docker and Vagrant and those kind of guys. Test the outcome on any level. Unit tests, UI, functional stress, counts, mutational, what's not, all that being automated now and can be done by machines as well. The outcomes are tested continuously on the CI servers, again in the cloud, on any number of agents simultaneously, and learn what's good, destroy the rest. This is what it said, right? And that's exactly what gives us this kind of automation. And I would say that that's a great thing. Probably some people will have to adjust and learn new skills to be able to do that. But generally, that's exactly what drives our industry forward. Once we give the things that we can repeatedly automate to machines, it allows us to do much more interesting work. All right, here's the shameless plug, 2 minutes of shameless plug. JFrog user conference, the Swamp Up, is going to take place in May in Napa, of all places. So if you feel like you want to learn a lot and spend some time in a nice environment, please join us in the Meritage Resort, May 23rd and 24th. We have great agenda, and I also have corks, wine and everything. Let me find one. Here we go. It's a USB drive. Innovation. So I don't have any USB drives at the moment, like because I throw them all away. If you are in the same position and you want one, I have a lot.
How do we know you haven't put malware on these? Easy. How do we know you haven't put malware on these?
Use it as a cork. So that will be all for me. Thank you very much. And now we're going straight to the panel discussion on DevOps. So our panelists, please come on.